Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. And this is a kind of a classic question from Algebra II. So it's worth talking about. You're likely to see this on a test in school or even on a standardized test on like the SAT or ACT. Okay, so the situation is we have a river. Here's the river. And we're going to put a fence around this rectangular space here. And we want to maximize the area of the fence, of the space here. So we have a width and a length here and a width here. So that's the fencing we're going to buy. So we know we're going to buy 1796 feet of fencing. So L plus 2W is equal to 1796. And we know that the area of this enclosure is going to be length times width. Okay. So now we're just going to write area in terms of either length or width. Doesn't really matter. I'm going to use width, I think, because the length, we're going to just rewrite this one as the length is equal to 1796 minus 2W. And so now I can write this as a function. I'm going to use a little different notation because I want to emphasize the fact that this is now a function of the width only. So here's a function of the width. And it's equal to the length, which we found is 1796 minus 2W. So it's just the length times the width again. And we write this out, we're going to get negative 2W squared. Got carried away with that. Negative 2W squared plus 1796W. And we know that if this were area and this were width, we'd have a parabola opening down. And it would go through the origin, because when there's zero width, there's zero area. So it would look something like this. We know that it opens down because the leading coefficient is negative. Okay. So obviously the maximum here is achieved at the vertex. And you're supposed to know somewhere along the way in your Algebra II class that the x-coordinate here is negative b over 2a. So let's go ahead and find that. Okay, so negative b over 2a is going to be negative 1796 divided by negative 4. So let's do the division on the calculator. 1796 divided by 4 is 449. And to get the area, we need to find the height of this parabola. So we're just going to plug this in. So A of 449 is equal to negative 2 times 449 squared plus 1796 times 449. And thank goodness for calculators. So this gives me negative 40,000, 403,202 plus 806,000. So we do that subtraction. And I get 403,202. So that's the area of the enclosure. And it's equal to 403,202 square feet. If we want the length, we just go back up here. 1796 minus 2 times 449. So the length is going to be, do this on the calculator, 1796 minus 2 times 449, 898. And if you like, we can go mark this on the diagram. It's always nice to get that visual going for you. And the width we found is 449. Okay, so that's it. So it's a nice problem. It's used all the time in school. So you should be very, very familiar and comfortable with this kind of problem. It's going to show up over and over. I hope this session was helpful to you, and I'll see you again next time. Bye-bye.